and welcome to Exponential Functions Part 2. Before we begin, I'd like to remind you that an exponential function looks like this. All right? In this case, with exponential, a is a number. So it's 2, it's 3, it's 5, it's 7, it's 254, but it's a number. All right. Okay, in this first few problems that we're going to look at, what we want to determine is whether the rule, so that's an equation, or a table represents a linear or exponential function. Let's begin with number 1. When we were looking at linear equations before, what we were looking for is for a constant rate of change between each pair. So let's see, what is the rate of change between 3 and 9? Well, that's adding 6. Between 9 and 27, it's actually adding 18. So this is not linear. Next, let's take a look and see if it is exponential. The first thing I see here is 3. 3 can be written as an exponent very easily, as most numbers can, 3 to the power of 1. Anything to the power of 1 is itself. It's pretty nice. Okay, the next number I have is 9. Is there a way that I can write 9 as 3 to the power of something? That you should be familiar with. 9 is 3 squared. Okay, so far so good. 27. Can I write that as 3 to the power of anything? Yes, 3 to the power of 3. All right, if this is an exponential function, then hopefully 81 can be written as 3 to the power of something. And sure, we have 3 to the power of 4. So it's exponential, and here's our explanation why. We can rewrite each y as an exponent. Beautiful. Let's continue to number 3. Number 3, 5 times 2 to the x. I'm going to zoom out a little bit, and on top I wrote, we need the a to be a number. So the base of the exponent. The base of the exponent right here is 2. Is 2 a number? Why, yes it is. This is an exponential function. The reason being, we have a base of 2. Let's look at number 4. In number 4, we have 6 times x to the third. A, the base of our exponent, has to be a number. In this case, the base of our exponent is x. X is not a specific number, so no, alas. Let's continue to number 9. Okay, so we're just evaluating this. So I'm going to write down how I will enter it in my calculator. 8 times 0.7 to the third. Now I'm going to do 0.7 to the third first. Then I will multiply it by 8, following the rules of the orders of operation. Now if you recall, it's PEMDAS, the E stands for exponent. Okay, so we have 8, whoops, I selected the thicker one, I don't want that. Okay, so we have 8 times 2, whoops, I multiplied, oh my gosh, I can't believe I multiplied 7 by 3. Shame on you, Miss Gumin, shame on you. 0.343. Okay, and then I'm going to multiply 8 by 0.343, and my answer is 2.744. Alright, not too bad that. You just have to be very careful and mindful of the order of operations. Whoops. Okay, word problem. I know these are your favorites. Let's take a look at number 14. An investment of $8,000 in a certain certificate of deposit doubles in value every 7 years. Here's the function. I'm going to highlight it because it makes it easier to see. X is the number of doubling periods. If an investor does not withdraw any money from his certificate of deposit, how much money will be available for withdrawal after 28 years? All right. So let's read this word problem again and make sure we have everything and not just the equation highlighted. I like to highlight it right away, makes it a little easier. Okay. We have an investment of 8,000 that doubles in value every 7 years. Okay, doubles every seven years, and X is the number of doubling periods. So the amount of 7 years that pass. And then we have 28 years. So I highlighted all the years stuff because that looks like we're going to be dealing with. Okay. Well, if there's 28 years and every doubling period is 7 years, the first thing I need to do is divide 28 by 7. So 4. There are 4 doubling periods. Since we know that, we can now find out how much this investor has in his bank. Let's do that by, I guess I don't need to write down the f of x. We're just going to plug it in 2 to the 4th. Okay, let's solve that. First thing I'm going to do is 2 to the 4th, so I have 8,000 times 16. Let's type that into our calculators. 8,000 to 3 times 16 is $128,000. That's a long time to wait for that amount of money, but hey, I'd be happy with it. I bet real banks and not imaginary ones and real investments don't get you that much money. Or maybe they do. I don't know. I'm just kind of rambling on. I hope you understood how to solve it, though. Let's see. Do I have anything else highlighted to go over with you? Yes. Okay, number 20. Evaluate each function over a domain of etc. As the values of the domain increase, do the values of the range increase or decrease? Okay, so that's a lot of words. Let's remind ourselves something. Domain talks about our x's. Range talks about our y's. So this problem is actually asking us to plug in a bunch of x's and tell us and then answer whether or not our y's are getting bigger or smaller. Okay, I'm going to zoom in. Where are we going from -2 to 3? Okay. Let's begin. 4 times 3 to the -2nd. Remember, when you're doing this in your calculator, the first thing you should do, because I don't want you to mess it up with all the parentheses, is raise 3 to the power of -2 and then multiply it by 4. So we have 0.44. Okay, I'm just going to go ahead and math it out. All right, let's plug in -1, multiply that by 4. Let's do 3 to the 0 times 4. That would be 4. 3 to the 2nd times 4 is 36. And lastly, 3 to the 3rd times 4 is, 27 times 4 is 108. Scroll over a bit. Whoopsie doopsie. 108. All right, so there's our range. Is it increasing or decreasing? It's increasing. Beautiful. And lastly, let's take a look at number 23. Which function has a greater value for x? Okay, so we have 2 types of functions here in number 23. We have an exponential one right here. And this is, we call it a polynomial. It's x to the 5th. Let's solve. If x equaled 2, here we'd have 25. For the other one, 2 to the 5th is 2, so 4, 8, 16, 64. I need to check because now I'm unsure, as always. No, it's 32. I overshot 32. So in this case, y equals x to the fifth will have a greater value. I hope this was helpful for your homework. Always feel free to ask me some questions if you have any. Yeah, have a great whatever rest of the day it is, and I hope to see you soon in school. Bye.